everybody, this is Mr. Munson. We're still in that Unit 1 that we're working through some basic geometry. The concepts we're learning here are, many of them you've already learned in a previous year's worth of math, right? But we're just building a very strong foundation in the terminology that we'll be using this year, some basic understanding. This is kind of what I call the 3 to 5 foot section of the pool. You shouldn't be drowning yet. And so if you are, no worries, you're coming to see me for help or asking questions in class. Um, this, like I said, this is the 3 to 5 foot section. We need to make sure that you have this firm understanding of these basic concepts before we move into the deep end of the pool. Otherwise, you're going to drown. So we're looking at 1.7, angle pairs and their relationships. Let's get started. Let's start by looking over our vocabulary words that we'll need for this section, maybe even some that we've had in previous sections or whatever. But if you don't have this sheet right here, no worries. Make sure that you understand the words that we're looking at on this sheet. Maybe you forgot to get it in class, you missed class, or maybe even I forgot to give it to you. But in any case, you'll get it, and you can go back and fill in the blanks. All right, so first up, an angle. An angle is basically two rays that start at the same endpoint, right? So, I'm just going to draw it over here. I'm not suggesting you do that. Here's two rays. They have the same endpoint. They form a angle. Those two rays are called sides of the angle. Okay? Remember, actually, we're writing the words on the back as a tool to allow us to practice and figure out these words later on as we are going to be held accountable for understanding of these. Now, you're welcome to write them like I am in the blank areas. For me personally, on my vocabulary sheets, I leave them blank, and I simply write them on the back and cut my sleeves and make it fold back and forth so I can check myself. Let's continue on, though. Next up is the vertex. In this drawing here, A is the vertex. It's the point that the two rays are coming out from. Go through a couple of words here now that are basic words that you've had in previous classes. Acute angle. Acute angle is an angle whose measure falls somewhere greater than 0 but less than 90. Then we have a right angle, and that's where it's equal to 90. Obtuse, where it's greater than 90, right? It's greater than 90. It's some value greater than 90, but less than 180. So it's trapped. Some number trapped between 90 and 180 is an obtuse angle. A straight angle is one where it's equal to 180. Basically, you have this ray that's been rotated over to this side, and the two rays actually point in opposite directions and form this 180 degrees of rotation, or a 180 degree angle. In an earlier video, I talked about the ability for us to add two smaller segments together to form a larger segment. Same thing's going to be true about angles. I can take two angles, and in this case, I have a small angle here and a small angle here, and I'm going to add them together to form a larger angle. And the two measures basically are added together to make it equal to the larger angle. Now, I'm blowing through these pretty quickly, and you might be falling behind. That's the beauty of a video lesson, right? You can put me on pause, back up. You can say, wait a minute, Mr. Munson, I'm still filling out the blank here or writing it over on the other side. No problem. I don't have to wait for you in the lesson. You just put me on pause. That's the beauty of the flipped classroom. All right, now we have the angle bisector. Basically, an angle bisector is a ray that cuts a larger angle into two congruent parts, right? So when we mark them congruent, well, we struck an arc. That's an example of a way of showing congruency. We have different ways that we've talked about. Now take a look at in this same block here for this angle bisector. There's some words down here written in bold, and it says, what does that arrow pointing in both directions mean in the statement above? And what I'm talking about is this thing right here. And basically, I can read this statement from left to right in words in English, and even though it's written in mathematical symbols. So listen for the words I say when I get to that arrow, okay? So the angle of XAY is congruent to the angle YAZ. Now, if you didn't put it on pause and write down the word congruent for that symbol right there, and you didn't know what that symbol meant, you were just missed an opportunity, okay? I want you to go ahead and put me on pause if you need to. Write the word congruent there and point to that symbol so that when I talk about that symbol, you know exactly what it means. It means two shapes are exactly the same, okay? So now we're at the arrow there, and what it means is the words if and only if. So now let me start again from the left and just read this through. okay? Angle XAY is congruent to the angle YAZ if and only if the measure of angle XAY is equal to the measure of angle YAZ. Okay, now we'll talk about that more and you get a little bit more familiar with it. If this doesn't make a whole lot of sense to you, I want you to have a challenge here. At the end of Unit 2, I want you to come back and look at this and see if it does make sense. If it doesn't, come and see me. If it does make sense, I want you to know that you learned something. That's what you're here in this class for. Complementary angles are two angles whose sum is equal to 90 degrees, okay? So here's two sets of angles. Over here are two angles that are right next door to each other. These are called adjacent angles. They share a common wall. And so 1 and 2 are complementary because when you put them together, they form that right angle, which we know to be 90 degrees. Now, they don't have to be right next door to each other. They can just be nearby, right? Or even far away. It doesn't matter. As long as the two angle measures add up to 90 degrees, we say they are complementary. Similarly, we have another word called supplementary, and supplementary angles are two angles that add up to be 180 degrees. So here's a set of supplementary angles, and later on we'll classify these as a linear pair. You'll see why. But look at that next angle. There's obviously not another angle there. What that is me asking you, what would be the angle missing here that would be supplementary to 137? That's the kind of question you might encounter in this class. Now we have adjacent angles, and I just kind of mentioned them. Adjacent angles, as you read through the definition, are basically two angles that have a common wall or a common side or a common ray like these do, okay? So 1 and 2 are adjacent angles, 3 is adjacent to 4, and so on. As you can see in the adjacent angles that these angles right here do not form a straight line, okay? They're adjacent for sure, but whenever we have a pair of angles that are adjacent and they form a straight line like this does, then that's called a linear pair. And so a linear pair are a pair of angles that are straight when they're put together, okay? Now, we have a postulate, as the next term is going to say. It's called the linear pair postulate. And basically, it says this. If I tell you, in my mind, whoops, I am thinking of a pair of angles called the linear pair, then you can automatically have the number 180 pop into your head because those form a straight line, and straight line angles that are adjacent form a supplementary pair. Both angles have to add up to 180 degrees. And then finally, at the very end here, we have vertical angles. Now, I got to tell you, I am really typical spelling this the wrong way. Matter of fact, I'm right now redoing this video because I had one posted and I had it misspelled. And for some reason that is just stuck in my head and it's hard for me. So if I make that spelling mistake, you just gracefully say, Mr. Munson, remember it's A-L, not L-E. Okay? And so a vertical angle pair, and this section is about these special angle pairs that we're dealing with. A vertical angle pair is just basically a pair of angles whose rays are opposite each other. Okay, so I'm going to look at the rays that make up angle 1. They're in green. Their opposite rays make up angle 2. I've done those in blue. Okay. All right, let's go ahead and move into writing some notes. Remember, if your previous video does not have a summary at the last part of it, draw your line, write the word summary, write a summary, go back and review your notes. This is very powerful for your learning. Draw another line underneath that. Now you're ready for today's video lesson. Okay, so we'll label it 1.7. Don't forget to put your date of the video. And then let's get going. So what I want you to do on the left-hand side is classify these triangles. You just had some video words that were given to you about classifying angles. So I want you to just put me on pause and see if you can classify these angles by their measurements. Okay, so you should have used words like acute, obtuse, right, and straight. Okay, that's how we classify angles. Now, a different kind of question, but sometimes very much misunderstood, are naming angles. So when we name angles, we use letters that identify which angle we're talking about. Not classification is those to the left. Naming angles are using letters. Okay. So what I want you to do is put me on pause and name these angles. So here's the first one. Angle ABC is shown here in the picture. Notice that the middle letter of my name is B. That's because the vertex is B. Okay? Now, if you didn't know what I meant by naming these angles, put me on pause and see if you can do the next couple on your own. All right, very good. Now we're looking at the last two being ABC and APC. Hopefully you got those right. Let's move on. All right, so we have adjacent angles. Adjacent angles are a pair of angles that have a common side, and so here we are. They have that common side, so we say BC is a ray that they have in common. Going on, we have vertical angles. Now let me just kind of pull some information away. So as you can tell by my writing, I say angle 1 and 3 are vertical angles. Here's the reason why. If you look at angle 1, which is marked with its sides highlighted in black, have opposite rays here that go up like this. Okay? So the blue are its opposite rays, and it forms the angle 3. The blue rays surround angle 3. That makes angle 1 and 3 a vertical pair. All right, and similarly, we have angle 2, which is done in black, and 4, which is done in blue. Those are a vertical pair. All right, let's move on. So let me show you something that's kind of interesting about these concepts that we have. If we look at angle 1 and 2, they're not a vertical pair. They're a linear pair. They have a common side, and they form a straight angle, right? So here's the straight angle that they form. So that's called a linear pair. And according to the linear pair postulate, those two angles form 180 degrees. So using that, I should be able to measure angle 2. Put me on pause and see if you can find out what the measure of angle 2 is. All right, so you're going to write an equation, subtract 84 from both sides, and I get the measure of angle 2 is equal to 96 degrees. Okay? All right, very good. Now let's ask a couple more questions. How about the measure of angle 3? Can you do that one? Put me on pause, then come back and check your work. Now, hopefully you concluded that angle 3 was 84 degrees. We know angle 2 is now 96 from our previous work. So 96 plus the measure of angle 3 should equal 180. When I solve that, I get the measure of angle 3 is 84. Now, 84 sounds awfully familiar, and you're right, because it's angle 1. And what I want you to get from this experience is a very big concept. Vertical angles are congruent. That's the congruent sign. Basically an equal sign with a little wavy across the side, okay, or across the top. So that's 84. These are vertical angles because their rays are opposite each other. Vertical angles are congruent now from this idea, and guess what? Can you calculate what the measure of angle 4 is without any calculations? Put me on pause and come back and see if you get it right. And that's a big fat 96 degrees. We got it. Hopefully you did. Let's move on. So here's some notes on complementary and supplementary. Remember, complementary angles are two angles that add up to equal 90 degrees. And on the right-hand side, two angles that add up to 180 are supplementary angles, okay? Now, certainly they can be adjacent angles like the ones on the left-hand side, or they can be angles that are not touching at all. They're just nearby or whatever, like those over on the right-hand side, okay? Supplementary, complementary. I find that a lot of times students have difficulty remember which one's which. You know, is complementary the one that's 90 or the 180? This is how you're going to remember. Complementary starts with C, as you can see here. And supplementary starts with S, like you can see here. And certainly everybody here knows that C comes before S in the alphabet. Well, 90 comes before 180 on the number line. Okay? Now, when you're dealing with this, always write an equation. Okay? Don't just go 90 minus whatever. Always write the equation and then solve for the unknown. That will allow you, when the problems get more difficult, you're used to writing equations in this class. You'll get even better at it. But the more you do it, the better and easier these problems will get. If you need to, I need you to put me on pause and write these notes down into your book. All right, here's an example problem. I'm told in the problem the given information is that the angles are complementary. So that gives me a clue what kind of equation I need to write. I see unknown, so I must write an equation. Remember, every equation has an equal sign. So the equation I'm going to write is 2x, which is one of the angles, plus 3x minus 5 equals 90. And from that point on, simple algebra. All right, try your hand at this try it problem. Put me on pause, come back and check, see if you did it right. All right, so the one angle plus the other angle equals 180 because they are supplementary. Now, I got to tell you, if you look at this picture, this does not form a straight angle. I don't want you to worry about that. I'm just a horrible drawer sometimes. But the facts are, here in red, I told you these are supplementary angles. Okay? So that's the facts. Write the equation, get it right. Okay? Now, if you notice at the bottom of the right, I just scrolled in a black line and summary, the word summary. That means we're at the end of our notes. I want you to draw that line. Just take a few seconds and review your notes and write a quick summary of what you learned. And of course, if there means you're finishing your summary, the next screen is your problems. Put me on pause. Okay, so here's your problem set. Hey, listen, I'm starting to see more and more students not writing down the original information, forgetting to circle their answers, and some it's starting to fish out. Some students are not taking very much time with these problems. If I can't read them, if you make it difficult for me, I can't give you credit, and I won't do that. So I need you to make sure that you're doing everything you need to for 100%. Let me scroll through the problem so that you can see them better. Have a fantastic day.